Welcome. We're looking at today's section 1.4. It's complex numbers. Again, hopefully this is a review to you. We'll start off with just basically what is a complex number or what is an imaginary number. If we have the square root of negative 4, that could be broken down into the square root of negative 1 times the square root of 4, which in turn, the square root of negative 1, we call this imaginary term I, and then the square root of 4 is 2, but we typically write the number in front of the imaginary term. Therefore, we get 2I out of it. Now, the majority of what we do in complex and imaginary numbers are the same thing as what we would do with any kind of arithmetic. There's an exception that we'll look at. But just starting out, if I have the square root of negative 1 squared, thinking about that, square root of negative 1, if we square it, would be I squared. Now thinking about what the square root of the square of a square root is, well, it's that value itself. So I squared is also just the same thing as negative 1. So we're sitting there and keeping that in mind. There is a pattern that goes on. I cubed is I times negative 1, which would be negative I. I to the fourth is, if you take I squared and square it, you get I to the fourth. Well, negative 1, if you square it, you get positive 1. And then the process repeats. I to the fifth is I to the sixth is negative 1, I to the seventh is negative I to the eighth is positive 1. So that pattern goes on indefinitely. If you wanted to know what I to the 73rd power is, and you get here, you say I to the 73rd, well, instead of writing it out that many times, you could take your 73 and divide it by 4. 4 goes into 7 once, 4, 33, 8, 32, and your remainder here is 1. Well, with that remainder of 1, what we see is that would coincide with what I to the first is. And I to the first is, of course, just I. So I to the 73rd is the same thing as I. If a number has a remainder of 2, it's negative 1. A remainder of 3, it's negative I. Now you might think, well, remainder of 4. Well, there is no remainder of 4. If the remainder is 0, then the number is 1. So if we have I to the 300th, 300 is divisible by 4, so it's just equivalent to 1. All right, so let's keep going from here. If we have the square root of negative 6 times the square root of 3 minus the square root of 2, well, first off, the square root of negative 3 minus the square root of negative 2 is not negative 3 minus negative 2. Or the square root of that. This is simplified. Nothing else we can do here. So what we need to do here is to distribute in. So I've got the square root of 18 and then minus the square root of 12. Now at this point here, we need to break them down as simplified as we can. This is 9 times 2, so it's 3 square roots of 2. And this is 4 times 3, so square root of 4 is 2, so it's 2 square roots of 3. So that's how we would break down the square root of let me make sure I got this right. The square root of negative 6 times the square root of negative 3 minus the square root of negative 2. Okay, from here, looking at a different situation, let's say that we have 6 minus, and then I've got 3 plus 2i. Now this is called a complex number. And then plus 4 minus 5i. So we've got a real number subtracting a complex number, adding a complex number. So this is 6 distributing in the negative. It's minus 3, then minus 2i. All right, and then plus 4, and then minus 5i. So at this point here, we would just go about collecting like terms. 6 minus 3 is 3, 3 plus 4 is 7, and then negative 2i minus 5i is negative 7i. So that arithmetic reduces. All right, if we have just basic multiplication, so let's just say it's 3 plus 2i times 4 minus 5i. We'll treat this like a binomial times a binomial. We'll distribute. 3 and 4 is 12. All right, then we have minus 15i. Your inner terms are plus 8i. And then we have negative 10i squared here. Well, negative 15i plus 8i would be negative 7i. And remember what we said earlier about I squared. I squared is negative 1, so this is minus 10 times negative 1, which would become plus 10. So 12 plus 10 is 22, so we get 22 minus 7i as our solution here. Squaring a polynomial, we get 3 minus I squared, and we're going to square it, or 3 minus just regular I squared. All right, so we square it, and remember we square a binomial. If you have a minus b squared, it's the same thing as a squared minus 2ab plus b squared. You don't just square your individual terms. You have to remember that this binomial squared means you're multiplying a minus b times a minus b. So what would 3 minus I times 3 minus I be? Well, you would have 3 squared, which is 9, then minus 2 times 3 is 6, so minus 6i, and then plus I squared, which is minus 1, so 9 minus 1 is 8, so we get 8 minus 6i when we do that arithmetic. Let's go with 2i squared plus 21 over 3 minus x. All right. Now, the trick to this, 3 minus 2i. The trick to this is to know that we need the final answer in the form of a plus bi. That would be a complex number. So we take care of the numerator. 2i squared is 4i squared, which is 4 times negative 1, which would be negative 4. So we have negative 4 plus 21 over 3 minus 2i, which is equivalent to negative 17 over 3 minus 2i, which is not in this form right here. So we do what we call rationalizing the denominator. There's a special case. Typically when you multiply a complex number times a complex number, you get a complex number. The exception to that is if you have conjugates. In other words, just changing the middle sign. So I'm going to multiply this by 3 plus 2i over 3 plus 2i. Now, When you FOIL this out, 3 and 3 is 9. When you have opposite signs here, that's what causes you to cancel out. You get negative 6i plus 6i, which goes away. So we have negative 2 times positive 2, which is negative 4. So it's negative 4i squared, which means it's plus 4. All right, then you have negative 17 times 3 plus 2i. So that's negative 51 minus 34i, which becomes negative 51 over 13 minus 34 over 13i. And 51 and 13 don't simplify. 34 and negative 13 don't simplify either. So this is the simplified answer. So again, your trick is if you have a plus bi times a minus bi, your answer becomes a minus b squared I squared, which becomes, I'm sorry, a squared, because a times a is a squared. That I squared there is negative 1, so it becomes a squared plus b squared. So that is a quick lesson on complex numbers, so you will have time to work on this lesson. Hopefully some of you will start it before we come back to class. Hope you've enjoyed the snow days. Bye.